for this question, let's start reading the question itself, right? Okay, as always, right? So let's see, the question is asking us to find the freezing point. Very concise, the question. Freezing point of a solution. Okay, so now that's something we need to pay attention, right? We're looking into freezing point of a solution. Okay, and then as we learned, right? Okay, so freezing point of a solution, what's the title for it? Freezing point depression. Okay, depression means what? Lowered, right? Okay, so then again, who are we comparing with, right? Freezing point of the solution, we're comparing with the freezing point of the pure solvent by itself. Okay, so freezing point of the solvent subtract the freezing point of the solution should equals to what? Okay, so again, think about which one's higher temperature. Freezing point of the solvent by itself is higher, right? Okay, and then freezing point of the solution is lower. So then when we do the subtraction, we're gonna get what? A change or the difference of the freezing point. Okay, so then this difference will be a positive value, right? Okay, so then that makes sense. Okay, so now again, we are looking for what? We are looking for what's the freezing point of the solution by itself. Okay, so of course we can reorganize, right, this setup. Okay, so the freezing point goes on to freezing point of the solution goes on to the other side. Then we got what we will do that freezing point of the solvent and subtract the change of the freezing point. Right? They simply reorganize the relationship. So now again, we know we're looking for this. So as long as we know this one and the change, they'll be able to solve the problem, right? Okay, so do we know the freezing point of the solvent? Go, nothing is given, okay, but then we have to realize what's the solvent in this question. Okay, so we'll have a solution, right, of sodium nitrate in water, right? So what's their role, right, in this question, in the solution itself? Water is our solvent, your sodium nitrate, that will be our solute. Right, okay, so very good. So now we know, okay, our solvent is water. Do we know freezing point of water? I think so, right? Okay, so that's 0 degrees C. Okay, so now we got 0 degrees C. Again, now the job is turning into calculate what's the change in freezing point for the solution in comparison is pure solid by itself. Okay, so now freezing point change, okay, equals to I times lowercase m molality times Kf, right? Okay, so then that's a constant. Okay, so now let's talk about these terms. Okay, I refers to, or I means what? Van Hoff's factor. Very good. Okay, so it's Van Hoff's factor. This concept relates to what? Electrolytes. And then this is about the solute, right? So then, which means we need to look into this sodium nitrate, okay, over here from the question, okay, as a solute, what is Van Hoff's factor I? Okay, so then this relates to what kind of compound it is, okay, and then therefore what kind of electrolyte. Sodium nitrate is a ionic compound. Okay, and then when you dissolve in water, it's 100%, right, dissociate into ions. Okay, so then that's why it matters to our freezing point, because as one compound, you put it into the solvent, okay, dissociate into two particles. Okay, so when you have sodium and nitrate ion. Okay, so again, I also hope that we understand nitrate ion is a polyatomic ion. Okay, so it stays together. Okay, has a negative one charge. Okay, so from one turning into two particles, and that matters. Okay, so then therefore the I will equals to 2. Okay, so then that's how we work on this one. Okay, so you can see as a one whole unit compound, how many particles it will turn into when you have in this solvent. Okay, so then that affects our colligative properties. Okay, so that's for that Van Hoff's factor. Now the next one is what? Lowercase m means what? Means molality. How do we calculate molality? Equals to moles of our solute over kilogram of the solvent. Okay, so now let's see our question. Oh, it's given. That's very nice. If it's not, then we have to just, based on the definition, then we can calculate that. Okay, so then for this one, it's nice, it's given. Okay, and that's good. Okay, the next term is what? Kf is the constant. Okay, so constant, that's about our solvent. And is it given? It's also given 1.86 degree per molality. Okay, so now that's nice. Let's plug it all in. Okay, so the change in freezing point for the solution equals to I is 2 for this particular question. Again, we need to look into, right, what kind of a solute we have for that particular solution, times this is 1.50 molality times Kf is given 1.86 degrees C per molality. Okay, always we have units along, so then we can cancel that out. Do the calculation. this number comes out as 5.58 degrees C. Okay, so remember this is the change. The question didn't ask what's the change, right? In freezing point, it's asking what's the freezing point for the solution. Okay, so then we need to go back into this relationship, right? Okay, so freezing point of the solution will equals to freezing point of the solvent, subtract the change, which we just calculated over here, 5.58. Then give us negative 5.58 degrees C. That's the answer. Okay, so that's the answer. And then again, just as a reminder, look at over here. That's only 0 because our solvent is water. If it's a different solvent, that will have actual value. So then you do the subtraction as you understand the relationship. But just as a reminder, you cannot simply go, oh, seems like it's a negative or opposite relationship. I just add a negative sign. That's not the conclusion, right? Conclusions, you have to use this relationship, okay, so to do the calculation. Okay, so this is an example question for freezing point of a solution. Okay, thank you for listening.